All right, guys, lesson 2 for your week. Remember, there are only 3 lessons, which is awesome. This one's on reading and making line plots, and I'm not totally sure what you remember back from 4th grade, if you remember doing any of these, or maybe you guys didn't get to them because it comes at the end of the year. But line plots are basically just a visual representation of data. So, what that fancy sentence means is you've got a frequency table over here, which is this over here. This is called your frequency table, and it gives you data or information that you gathered, and then a line plot is basically just a way to show that data. So it says 2 number cubes labeled 1 to 6, which we also know as dice, were tossed 30 times. This frequency table shows the number of times each total occurred, and it says you can organize data on a line plot to make the data easier to analyze. So here's what they've done so far. It says the line plot has been filled in for tosses of 2, 3, and 4, and it wants you to complete the rest of the line plot. So that means that they did 2, they did 3, and they did 4. So that's the first thing that we're going to do, is we're going to find 5. That's if you rolled the number dice, or the cubes, and you were to come up, you added the 2 together and you added it to be 5. That happened 3 different times. So over here for number 5, we're going to do 1, 2, 3 dots for 5. Sorry, that doesn't look very straight. You get the right idea. So then for so the next part is for how many times the 2 dice added up to equal 6. That happened 5 times. So that's going to be 1, 2, 3, 4, 5 times. And then for the 2 dice adding up together to equal a total of 7, that happened 6 times. So we would do 1, 2, 3, 4, 5, 6. Then for the 2 dice adding together to equal 8, that happened 4 times. So we'll do 4 dots. And I hope you can see that I'm just getting that information from over here on the side. And then for 9, for adding them together to equal 9, that was also happened 4 times. Oops, I didn't do a great job of that. I might actually erase that. Can you see how they should kind of be lined up a little bit, meaning that these 4 dots line up with these 4 dots, and that just seems a little tall. So I think I'm actually going to redraw that. Thanks for being patient. And it's okay if yours isn't perfect. It just is nice to stay consistent. Okay, that looks better. And then for adding up the 2 dice to equal 10, that only happened twice. And then for adding up all the dice to equal 11, that only happened once. Okay, so that's what our line plot ends up looking like. And I also want to help you with one more thing. You also need to have a label of some kind. It wants us to complete the rest of our line plot, but it also needs us to make a title here. So what I think of this title is that this is basically the totals for 2 cubes added together. So that is exactly what this line plot shows us. So take a minute, go ahead and write that down. Make sure your line plot looks similar to mine. Totals for 2 cubes added together. And this is the frequency that happens. So you should probably start to notice something. I'm going to draw this. I really don't want you to, so just watch me first. But I want to kind of show you what we see happen here. Go away. Is that you're kind of creating a little bit of a rise and then a fall. And that's going to be kind of interesting to look at when we look at the rest of these questions. So I've gone on to the next page. I already had done a little line plot already, so ours should look similar. And this says, based on this sample, describe the totals that are least likely to be tossed. Okay, so that means like, if you had 2 dice and you were to do this 30 times on your own, what do you think that you would possibly never even land on based on this frequency table that you see right here, or this line plot? And that to me looks like it's going to be 12. So 12 is the one that we never landed on, or they never landed on in their example. So it says 12 is likely not to be tossed. Or you could say rolled, too, since we normally roll dice. Don't care. And again, the reason that we're saying that is because there was no instance of that when they first tried it the first 30 times. Because then the question for number 3, it says, based on this sample, which is our line plot up here, what are the totals that are most likely to be tossed? And although we have a bunch that are similar, the one that is the most likely to be tossed is right here at number 7. So we would say 7 is most likely to be tossed or rolled, whatever you said. Give you a second for that. So, it says, number 4 says, why doesn't a total of 1 appear on the line plot? And you have to remember, this is meant to be 2 dice or 2 cubes added together, and you can't add 2 cubes together. There's no 0, so you can't even make it to 1. So 1 is not an option, is all I would really look for there. 1 is not an option. Okay, the lowest you could go is 2. We call that snake eyes, if you've ever rolled dice before. But number 5 is definitely the one that I want to talk about the most. So it says, explain why a total of 7 was the most likely sum tossed. So you have to remember your dice here are between 1 and 6 for both of them. And 7 ends up being the most likely because you can reach 7 the most often. What I mean by that, for an example, if I was trying to roll 5, meaning I would add the 2 dice together to equal 5, my only options are 1 plus 4, or I could roll a 2 and a 3. There's no 0, so I can't do 0 and 5. So the only way to equal 5 is if I did 1 plus 4 and I did 2 plus 3. But look at all of my options for 7. I could do 1 plus 6, I could do 2 plus 4, and I can do 3, sorry, that's 2 plus 5, my fault. And I can also do 3 plus 4. So because of that, that's the one where I have the most occurrences of equaling that number. So there's just more opportunities. I could roll a 1 and a 6, a 2 and a 5, or a 3 and a 4, and I will add up to 7. Whereas if I was trying to roll a 6, I could only do a 1 and a 5, a 2 and a 4, or 2 3s, but 2 3s can be hard because it's hard to roll the same number. So 7, it's my teacher manual says, because there are more combinations possible that result in the sum of 7, I would expect the sum 7 to occur most often. You don't have to write that all down. But let's go ahead and zoom to number 6. Number 6 is an opportunity for you to do this again with me, and we're going to make another line plot. So this says, for 10 days, Mario measured the amount of food that his cat Toby ate each day. The amounts he recorded are shown in the table at the right. Graph the results on the line plot. Excuse me, hiccups. So I'm going to get my pen, and I'm going to change the thickness so you can see the dots a little bit better. So it's basically telling me that he ate a quarter cup 2 different times. So, oh gosh, we can't do anything yet because we need to label our line plot here. So it looks like we go all the way from 1/4 to 3/4, but that we also have eighths here. So I don't have to necessarily include all of this information on my graph, but I do need to include at least the numbers that are off here to the right. I see 1, 2, 3, 4, 5 numbers, and I see 1, 2, 3, 4, 5, 6, 7 lines. So maybe I'll do a line before 1/4, and maybe I'll do a number after 3/4. I think maybe that will help. Do you see here how we're counting by eighths? And I just said I have 1, 2, 3, 4, 5, 6, 7. I think I'm going to do this. I think I'm going to start with 1/8. Oh gosh, that's way too big. Sorry, guys. You should go ahead and label that. Just make your line not so crazy big. I'm going to label this first one 1/8. You don't have to worry about the cups yet. Next, I'm going to do 1/4 because that would be like 2/8. Then I'm going to do 3/8. Then I'm going to do, that's a 3, I swear. Then I'm going to do 1/2 because that would be the same as 4/8. And then I'll just keep going. 5/8. And then instead of 6/8, I'll do 3/4. And then finally 7/8. Okay? I also need a label for mine. And they told us in the problem that I'm measuring how many cups of food Toby ate over 10 days. Something like that. I'll give you a minute to get caught up. And pause the video if you need to. Okay, so for 1/4 cup, now I'm able to plot this, and it looks like Toby did that twice. So I'm going to come over here to 1/4 cup, and I'll be able to do 2 dots for 1/4 cup. For 3/8 cup, he only ate that once. For 1/2 cup, he ate that 1, 2, 3 times. For 5/8 of a cup, he ate that 1, 2, 3 times. And then for 3/4 of a cup, he ate that once. So our line plot looks a little bit like that. Go away. There we go. And now I want to talk to you about A and B. So A says, what is the total amount of food Toby ate over the 10 days? And explain how you got your answer. Well, I basically need to add these totals up. And then, well, I guess maybe I need to add first how much it is per line, and then I can add those all together. So this is just simply an activity where you're going to add them everything together. So 2 groups of 1/4 cup would be 1/2 cup. 3/8 cup is all by itself. Here I have 3 groups of 1½ cups, so that will actually be 1½ cups. I have 3 groups of 5/8, so that's going to be 5/8 times 3, which ends up being 15/8, which ends up being 1 7/8. So plus 1 7/8. And then finally there's 1 group of 3/4 cup. So then I'll add 3/4 cup. So you guys remember you need to have some equivalent fractions. I know this seems like a lot of work, but I actually don't think it's too bad. 1/2 is going to be the same as 4/8. Your 3/8 is going to stay like that for now. And then you're going to have plus 1½ so that's going to be 1 4/8. And then you're going to add 1 7/8. And then you would have added 6/8. So all of that work is just to say your 8s now are good, so you can go ahead and add these together. 1 plus 1 would equal 2, so your whole number is taken care of. And then 4 plus 3 is 7, plus 4 is 11, plus 7 is 18, plus 6 is 24. So this would have been 2 24/8. However, we wouldn't leave it like 24/8. That would give us an answer of 5. Okay? And then it says, what amount of food would Toby get if the total for 10 days was distributed evenly each day? So that's basically saying if he ends up eating 5 cups of food by the end of the week, and they were to give him the same amount every day, that's basically like splitting that up among 10 days, and that means he'd get 1/2 cup every single day. So I'm actually not going to solve number 7 for you, but I'm going to help you a little bit. It says, Lily bought a bag of beads of mixed sizes. She made the frequency table below showing the number of beads of each size. It wants you to make a line plot using her data, and then you're going to write a question. You're going to write any question you want. I'll give you one example. Maybe something about beads that had a diameter, because it says diameter of beads. So how many beads had a diameter of 1/4 inches or less, something like that. So you need to write a table label, you need to plot those lines, and you need to come up with a question to ask. That would be super cool. And that's actually how you can show me your work today. So that's one option. You could simply show me your work for finishing that problem. If you don't want to do that problem and instead you'd like to go do the homework pages, that's also totally fine with me. And there are also some really good IXL lessons. Maybe that's the way for you to go. But otherwise, make sure you go show some work for lesson 8-7. Thank you.